Okay, let's take a look at this here. We're going to actually review plotting, kind of where we end up with last time. See if you guys remember some of these details. Today we're going to convert. And anyway, let's get started here. So remember, r theta, we're plotting in polar form, or polar coordinates. R is your radius, theta is your what? Angle. So here again is our polar axis, and we should say at the center here is our pole. Okay, theta here is 0. So if we're going to plot -2, this is our r value. We're going to review that. R, my angle theta. Let's stop and think about this. What is the angle? If they say pi over 3. Isn't that 60 degrees here? So here's my 60 degrees. And again, every dash mark here, this represents, if we can see 1 unit, 2, 3, 4, 5, 6, and 7. If my radius is negative, it's on the opposite side. So here's -1, -2, -3, -4, -5, -6, -7, -8. So because my radius is negative, where is this particular point going to be? What's the radius again? -2. So we're going to have to go out 2 units in the opposite direction, and it would be right here. So that first point for number 1 is located in blue. So does anybody have any question on that one? If we call this point A, we just labeled point A here. Okay, you guys okay with that one? We're going to review plotting really quick. That's number 1, that's A. Let's call the next one here B. And notice what the radius here now is for B. Okay, so I'm going to erase everything here. Okay. For B, your radius is 0 here, and the angle is pi. So I'm going to rotate pi, 180. And then my radius is actually 0. So what does that mean if the radius is 0? Yeah, just stay where you're at. Don't even move. Where are you going to be? Right at the pole. So we're going to say here then, this is the location of point B. Okay? Now let's look at C. We'll call this point C. What's the angle here? What's theta in this example? Right? What's your theta? Isn't that -pi/4? I have a negative angle. So what is pi/4? 45. Is that true? So I have to rotate -45. Where would that be then? Let me change this color again. Let's be consistent. -45, that's 360 minus 45. What do we get? Is that what we're talking about here? Maybe I should, let's put this in red maybe. So this would be negative what? 315. That's -45. Or the angle is -pi/4. Okay, so then what this also says is every radius along this particular line. Let me draw this line carefully. That's -pi/4. Every value here is positive. 1, 2, 3, 4, 5, 6, 7. Those are all positive values. So what number am I going to look for this positive radius being 4? I have to go out to what? 1, 2, 3, 4. In other words, we're right here. So this is the point or the location of C, where you have a positive radius of 4, but a negative angle of -pi/4. So we're going to review how to really plot here. All right, you guys okay with that one? That's C. All right, now we're going to look for -3 and then it's going to be negative pi now. So I'm going to erase some of this here. Okay, let's keep in mind again, we got our polar axis, angle theta is 0. We're now looking at an angle of negative pi right over here. So here's the deal. Where is negative pi going to be? Anybody know where negative pi is? We start at 0, and let's rotate what? We're going to rotate clockwise. This is where negative pi would be. So let me actually label that axis and say if we start with the polar axis and we rotate negative pi, again, this is my detailed, this is my detailed axis here. Every value here on this axis will be positive. So I'm going to say that, let's notate, positive 1, positive 2, positive 3, positive 4, positive 5, 6, and 7. They're all positive. But what do you know about this particular radius value? It's negative. So where would the negative be? On the other side, on the opposite side. So this would be where negative, and it's going to be hard to see, I guess. 1, 2, 3. That's where negative 3 is. And that's the location now, let's say, of point D. So point B, we have to get rid of because we can't see things as clearly now. And this is the location now. If we say this is going to be A, B, C, what? This is the location of D. And D is at negative 3, negative pi. So you start with your angle being negative, and since the radius is negative, it's on the opposite side. Okay, you guys okay with that? Is that pretty good? Should I erase some of these, or is it starting to get a little hard to see? At least for me it is, so I might start to erase things. Let's look for E now. But before I do, make sure you have this. If not, just go rewind the video. And let's start to erase some of this stuff. Okay, here's the prior problem D. Now let's draw the polar axis again. Corresponds to theta being 0. So E is at, let's see, what's the radius? Negative 1, and what's the angle? It's minus 3 pi over 4. So what do you think that looks like for us? Anybody know? It's negative, so we rotate how? How do we rotate for negative angles? Rotate what? Clockwise? This way? So pi over 4 is right here, negative pi over 4. An additional negative pi over 4 is over here. So what do we need to have? A third what? Pi over 4. So this is minus 1 pi over 4. This is minus 2 pi over 4. And this will be minus what? 3 pi over 4. So that the angle here, this negative angle, is right here. Okay, so far so good. We're rotating clockwise. That means our angle is going to be negative. So that's negative 3 pi over 4. Now every value on this axis that you see shaded red has a positive radius. In this problem, the radius is actually what? Negative 1. So where is that going to be, the radius of negative 1? It's going to be where? Opposite. This is where all the negative radiuses will be. Looks like it's right here at negative 1. So let's actually shade that. We'll erase this first one so we can see better. And this is now E, and we'll label it. E has a radius of negative 1, and and an angle negative 3 pi over 4. There you go. And this is the location right here. So this is how we begin to plot these points. And now that leaves us to F, which is at pi over 6. The angle's positive, and the radius is negative, so that we'll get full circle. Anybody have any questions so far? Okay, should we erase everything again? All right, let's try to get rid of this stuff. You can watch the video. Let's erase this. Let's erase everything. There we go. All right, polar axis right here. Let's rotate this polar axis. What angle do we rotate it now? Pi over 6? Where's pi over 6? 30 degrees right here? Okay. So let's say this, every value here is positive on this what? On this axis. Is that right? The negative radius values are opposite. So if I have a radius here now of negative 2, right here, it's going to be opposite. It's going to be on the other side over here. So we look for 1, 2. This is the location of F. Has a radius of negative 2, but an angle pi over, looks like 6. So this is a review here of how to plot points in polar form. Okay, you guys okay with that? Or theta. Pretty big deal. Anybody have any questions on that one? Okay, let's erase now. And I want to kind of build up some framework here for us, some equations. Let me do the following, though. Let me change this here. I'm going to superimpose. This is my polar graph, my polar form. Everything's written in terms of r and theta. So if I superimpose, I'm going to start by looking at some facts here. Here's my x-axis. And then here's my y-axis. Okay, in other words, there's this imaginary Cartesian coordinate system over my polar system here, okay? So let me get rid of this, get rid of this. You guys see the point. So I have an x-axis, I have a y-axis. Maybe I should be very technical, put these lines, and just remind you of something that looks like this. I'm also going to do the following here. So let's kind of build this up. This out here, I'm going to say, is a point P. Okay? So here's some point P. Point P has r theta in polar. Has that address. But if I look at some details here, if I draw this triangle now, notice this distance is x and this distance is y, and this is a triangle. So this distance is r. And I have an angle theta here. So far, so good? Okay, you guys okay with that? All right, let's consider what's going on here. Okay, tell me if you guys agree with this statement here. Let me write this down. What I know is simply that cosine of theta, what's this defined to be? Cosine theta. Anybody know what the definition of cosine is? Isn't that adjacent over, which really means x over what, r? And what is sine theta? Opposite over hypotenuse. And what does that mean? It's y over r. So for cosine, what we did was we took x over r by definition in this right triangle. And for sine theta, we took y over r, which is what it is by definition. That's the definition of our ratios. What this means for us is the following. This means that x is r cosine theta, and it means y is r what? Sine theta. So this is at least part of a relationship we're going to start to use. Now notice something interesting about this idea. Note, if you give me a radius and an angle theta, if you give me a polar point, a point in polar coordinates, notice what I can do. These are polar coordinates. You give me an r and a theta. Here's my r value. Let me go here. And here's my theta value. What do I get? I get a what? I get x and y coordinates. So any r theta, any point in polar, can be converted to what we call rectangular. So we do that. This converts to, I'll write it in red, rectangular coordinates. And that's how we do it. And then I'll say to you, similarly, how do we go the other way? Well, let's also notice some interesting relationships. Go back to this triangle we're looking at. Does anybody know anything else about this triangle? What do we know? We got a right triangle here. And don't we know something very special about right triangles? What's Pythagorean theorem? X squared plus y squared will be what? R squared. That's good. Okay, x squared plus y squared is r squared. Also, I'm going to point out to you another idea. Tangent theta, by definition, what's tangent theta? Isn't that opposite over adjacent? For tangent theta? What would that mean here? Y over what? X for this tangent of theta. So we're going to generate that equation too, and this gives us y over x. These two. We're going to also use. Now you might say, how are we going to use those? Well, we're going to use it this way. Let's note. I have r squared equal to x squared plus y squared. I have tangent theta equal to y over x. Okay? If you give me rectangular coordinates, this is what I'm saying. Rectangular coordinates of the form x and y. If you give me x and y, I square them and add them. Here I divide them. Notice what I get in return. I get an r value and a theta value. So this approach here, when I use these equations, will give me essentially a conversion to polar. This converts to polar. R value, theta value. Okay, so far so good? So this is our conversion format here. So you can study that and take a look at this. It's in every book. This is the approach. we could describe this point P two ways, rectangular and what? Polar. Now, I want to ask you guys to remember that in rectangular, our points are well defined, but in polar, they're not. In other words, we got this coterminal business. Remember that? We got different ways to describe the same point in polar. So in other words, polar is not unique. So I want to remember this, and I'll probably write it down for myself, that polar coordinates are not unique. Okay, so that's going to be an issue for us. So I want to write that down. The r theta is not unique. What does unique mean? One of a kind. I can describe this point many, many different ways. In fact, infinitely many different ways. But I can't do the same for rectangular. It's just going to be x and y. There's only one way to define those. So you'll see what we're talking about, as we go along here. So let's start with the first example. We're going to convert here polar to rectangular. Okay? So let's start to convert polar to rectangular. Let's look at an example. So if you're looking at a point here that looks like 3 comma pi over 4. Just looking at that pair of numbers, you're not just quite sure what that means, right? But if they tell you, you're going to convert what? Polar to rectangular. What that means is they're looking at this value being r and this value being what? Theta. So you're going to convert polar to rectangular. They're going to want to know what x and y is. So what do you use when you convert polar to rectangular? You go back to this set of equations. This gives you my x coordinate. This gives me my y coordinate. So let's see what that says. X equals r cosine theta. And y equals r sine theta. R here is what value? R is 3. So we replace R with a 3. And then what's theta?
40.
Pi over 4. Good. 45 degrees. 3 pi over 4. So you guys have to tell me now, this is x equals 3 cosine pi over 4. And y equals 3 sine what? Pi over 4. Do you guys happen to know what cosine pi over 4 is? Square root of 2 over 2? Is that true? What's sine pi over 4? Square root of 2 over 2? What's this coordinate? 3 square root of 2, 3 square root of 2. So, if I go back up here and I erase all this, what that really means for us, x-axis, y-axis, is that the coordinates 3 pi over 4, if I look at this, to graph this in polar, here's my pi over 4. 1, 2, 3, right here. This location here has two representations, or I should say this polar representation could be described rectangular as simply 3 square root of 2 over 2, 3 square root of 2 over 2. This is in terms of an x-y coordinate system superimposed of your polar. That's the same point. And it's the same point as the original r theta, which is going to be 3. Remember that? What's the original? 3 pi over 4. Can't see it. Let's put it over here. That's really just what they're saying for you to do. Okay, so we can do a few more, then we'll go the other way. But anybody have any questions on what you're looking at here? No? Okay. So let's do a few more. Let's say we convert negative 4 pi over 6. Okay, this again, reminding you, this is r theta, and x will be r cosine theta, y will be r sine theta. Okay, what's r going to be? Anybody know what r is? Negative 4. So wherever there's an r, we replace it with a negative 4. And what is theta? Pi over 6. So wherever there's a theta, replace it with pi over 6. So let's see what happens here. X is negative 4 cosine pi over 6. Y is negative 4 sine pi over 6. Anybody happen to know what's cosine pi over 6? Pi over 6 we already know is what? Is that 30 degrees? Everybody okay with that? So how do you get cosine pi over 6? What's cosine 30? What is it? I don't hear some confidence. What's cosine 30 degrees? Cosine pi over 6? I don't know. Anybody second that? You guys have to be confident. You have to know that. Okay. And what's sine 30 degrees? What is it? Okay, good. I don't know. You guys don't sound so confident. Let me double check. You guys are not confident here. Let's see. This is supposed to be 60, 60, 60, 2, 2, 2. We're going to what? Bisect. Okay. What does that create for us? What's this distance? Now this is 1. And this is square root of 2. Okay. So what's the definition of cosine? Sorry, not square root of 2, square root of 3. What's the definition of cosine here? Adjacent over hypotenuse. So that looks like it should be square root of 3 over 2. Okay, good. What's the definition of sine? Opposite over hypotenuse. All right, you guys are okay. Okay, just double checking. So let's simplify this. X will be negative 2 square root of 3. And over here, what is y going to be? Negative 2. So the Cartesian coordinate system here will give us, or the rectangular coordinates, is negative 2 square root of 3, negative 2. Here's what you have. Okay, so this is how I convert. Let's double check now. Here's what I want to check. I'm going to go back all the way to what we're looking at here. The original coordinates, what did they tell us? What was the polar coordinates here? In polar, we want to convert what? Negative 4 pi over 6 in polar. So pi over 6 we already know is 30 degrees. Is that true? Is that right? So pi over 6 we know is 30 degrees. So I guess I'll look at it this way. But my radius is what? What's the radius? Is that negative 4? So in other words, the point is opposite. Is that right? All right. So I have to go out. Let's see. 1, 2, 3, 4 units. There we go. That's the location of my point in polar form. The reason I'm bringing this up is because of the fact that what's your x coordinate and y coordinate in rectangular? What do we say they were? What was that first one? Is that negative 2 square root of 3? And what was the second one? Negative 2. This is my x coordinate, and this is my y coordinate. Double check. Tell me if you guys agree with this. This statement here says x is negative and y is what? Negative. They're both negative. So I want to emphasize this. X is negative, y is negative. In Cartesian coordinates, x versus y, what quadrant does that mean you're in? Third quadrant. Is that right? 1, 2, 3, and 4. So if I go out a distance here, this is my x distance. This should be negative 2 square root of 3. And I go down this distance here, that should be negative 2, somewhat, if I'm careful. Okay? You guys with me on that? What you're looking at here is consistent, meaning you have a point that's in quadrant 3. So you have a quadrant 3 point because they're both negative for x and y. So I want to really emphasize that you're really placing this Cartesian coordinate system over this polar system, polar coordinates. And, you know, it's actually consistent. So I want to point that out. All right? You guys okay with this one? This is converting, and we're noticing the consistency. So let's do another one. Let's convert. For example, let's see what they have. Maybe they have some interesting examples here. All right, how about if let's do something kind of trivial. What if they say 0, 6 pi? And it's not that trivial, but here's my radius, here's my angle theta. Let's say x will be r cosine theta, y will be r sine theta. My radius is 0. 0. So what's my angle? 6 pi. 6 pi here, 6 pi here. Zero cosine 6 pi. 0 sine 6 pi. Well, 0 times anything is 0, but I also know that these are, well, this is not 0, by the way. That number's not 0, but I really don't care. Because if I multiply any number by 0, here, here, what happens with the coordinates? X is 0, and what? Y is 0. So this is the origin. Is that kind of consistent? I mean, is it consistent if I say that's the origin? How do we know? Let's go back. Okay, let's go back. That's fine. We'll go back here. Let's erase everything here. What was the polar representation? Does anybody remember? 0, 6 pi. Okay, so if I have a polar axis here, that corresponds to angle theta is 0. That also corresponds to theta being what? 2 pi, 4 pi, and 6 pi. So there's my axis. So I can tell you that this theta here is actually 6 pi. You're looking at taking the polar axis and rotating it 6 pi, positive, right? Positive direction. We rotated that this way. I'm sorry, counterclockwise. Sorry, yeah, counterclockwise is positive. So I rotated that 6 pi. What's my radius? 0? Where does that place me? Right there, right at the origin. So this is 0, 0 in rectangular coordinates and 0, 6 pi in polar coordinates. This point is not unique. In fact, 0, any angle for any theta will give me the pole. So you're looking at the pole in polar, but you're also called the origin in what? Rectangular. 0, 0. So there's some consistency there, okay? You guys okay with this? It's pretty good stuff. All these little details just to start to graph. And then, for example, if we take a look at one more, let's just say -1, 5 pi over 2. Here's my r, and here's my theta. R is -1, so we're going to place r with -1. Theta is, what's theta? 5 pi over 2. Replace theta with 5 pi over 2. So does anybody happen to know what are the values of cosine and sine now? I don't know, 5 pi over 2. Let's see. Anybody know where that is? Let's think about what's 5 pi over 2.
We passed it. It was on top.
Sorry, looking for my graphs. Yeah, whatever. 5 pi over 2.
It's gonna be in the 90 degrees.
Is that 90 degrees? What's that coterminal to? Do you guys know this? 5 pi over 2. Okay. This is 1 pi over 2. What's this? 2 pi over 2. 3 pi over 2. 4 pi over 2. 5 pi over 2. You're right. 90 degrees. What was the radius here? So if I say let's go up 90 degrees here. What's your radius? -1? Was that -1? Okay, so it's opposite, right? Right. Let's say right here. Okay, I know it's hard to see. Okay. Negative radius are opposite. So here's my polar form of -1, 5 pi over 2. So far, so good? Okay, we're going to have to convert this. Let's find these values here. So x is going to be -1. What's cosine 90? Cosine 5 over 2. Anybody know what that is? 0. What's sine 90? 1. This means that x will be what? 0. And y is -1. We've converted. 0, -1. Is that consistent with what we drew? It is. Okay, so that's the point of 0, -1 right here. Okay, let's do the reverse. Okay, anybody have any questions on this here that we just did? Let's reverse this now. So they're going to give us rectangular now, and we're now going to have to get what? Polar. So let's start with the fact that they give us -1, 1, and this is rectangular. We're going to convert to polar. R theta. So what do we do? What do we use? Anybody remember? R squared is x squared plus y squared. And we also use tangent theta being y over x. So let's try this conversion here. Okay? What's x again? -1. What's y? +1. So wherever there's an x, you put -1. Wherever there's a y, you put +1. So we get r squared going to be, let's be careful, -1 squared plus 1 squared. R squared will be 1 plus 1. Well, r squared is 2. So by the square root principle, r will be plus or minus square root of 2. These are two values. Two values for r. Can r be positive and negative? Sure can. Okay? Now let's find theta. Tangent theta, well, what's the value here for y? We need a y value. Anyone want to tell me what it is? 1. We also need a x value. What's the value for x?
-1.
There we go. Tangent theta is -1. If tangent theta is -1, what's theta in my restricted domain from 0 to 2 pi? Anybody know what that is? What's theta? Is it 5 pi over 4? Anybody want to tell me? Is that right? Is tangent theta 5 pi over 4? Tangent theta being -1? No, that might not be right. Anybody know what's theta? How do we find tangent theta is -1? Are they two quadrants? You guys did those homework? Tangent theta is -1. Two quadrants here. Let's double check. So remember, you have a reference angle here that's positive, meaning tangent theta is 1 only when theta here is pi over 4. That's my reference. Here's pi over 4. Another reference, pi over 4. What do we get? Theta is going to be pi minus pi over 4. What else do we have? 2 pi minus pi over 4. So what are my two theta angles? It's 3 pi over 4. And what else? 5 pi over 4. Is that true? So I'm going to ask you guys this question here. Let me put this in red. What does this mean? We got a bunch of information we have to use here to describe our location. Okay. I'm going to do this here. See if I can do this here. Looks like I have to erase this. Okay, good to know. This is all from last question. We're going to go back, we'll erase all this. Good to know. And we'll copy this. I don't know. It might, yeah. I'm thinking of that 5 pi over 4 answer. Thank you. You're right. 7 pi over 4. It's always good to do the arithmetic. 8 minus 1. There you go. So there you go. These are the angles here. Let me erase this here to be clearer. This is the first angle. 3 pi over 4. Okay, and you're right. We'll say this is going to be what? 7 pi over 4. We're back to this. What does this mean? Well, let me go back and remind you guys this question here. This means a lot of things, or I should say it means a few things. What quadrant does this point live in? Anybody know where negative 1, 1 lives? If I had to plot this, negative 1, 1, that's in quadrant what? 2, is that right? So if I go over here, and I know I have an x-axis and I have a y-axis. Here's my x-axis, here's my y-axis. X is what? Negative 1, y is positive 1. Ladies and gentlemen, that means I'm over here in quadrant 2. You with me on that? So in rectangle coordinates, rectangular coordinates, negative 1, 1, the x-coordinate is negative, y-coordinate is positive. That puts me strictly in quadrant what? Quadrant 2 here. So any r theta I use must also put me in what? Quadrant 2. You with me on that? Okay. So let's say, well, how do we do that? You go, what does this mean? Well, I got two radius values. Radius is positive square root of 2. Radius is negative square root of 2. Okay? I know my theta is 3 pi over 4. So notice, if I use a theta of 3 pi over 4, which happens to be what? Does anybody know what 3 pi over 4 is? What's 3 pi over 4? What is it? Good. Here's my 3 pi over 4 angle. Same angle you're seeing right here. Quadrant 2. So if I use a positive value, meaning 3 pi over 4 for my angle, what does my radius have to be? Positive or negative? Let's see if you're awake. Let me do this. We're in quadrant what again? Quadrant 2. Theta is right here. We took the polar axis, we rotated it 3 pi over what? 4, counterclockwise. Any angle on that purple polar axis that was rotated is always positive. Is that true? Opposite angles, or I should say opposite of this, you'll have negative radius values. Oops, that would not be 300, but it would be what? 315. So if I use positive what? Square root of 2 for r, then I would actually be at a location consistent with the rectangular coordinates. Meaning, square root of 2 is about what? Anybody a little bit bigger than 1? Something like this. The point I'm making is, this here, 1, negative 1, is in quadrant what? 2. My radius being positive and my angle being positive also puts me in quadrant what? 2. So that is a solution. Okay? Now remember, what do we say? This is not unique. What does not unique mean? There's another way to describe that. Now you might say, well, how can I also describe that? Let me tell you how you can. If I took the angle 7 pi over 4, right over here, I'll erase this, and I'll say to you, let's take this angle, 7 pi over 4. Is that a solution? Yeah. So I can say 7 pi over 4 is my angle theta, but what would the radius have to be now? Negative. Good. I'd have to say that my radius now is negative square root of 2. And you might say, why is that? Because 7 pi over 4, if I change the color, let's change it to green. 7 pi over 4 is actually where? Right here. Is that true? Isn't that in quadrant 4, like we said 7 pi over 4 would be over here? Isn't that the other solution for tangent theta being -1, 7 pi over 4? So this here is 7 pi over 4. But what do you know about your radius? In other words, this point is opposite. So it has to be, if I say to you guys, let's find another color. Every radius on this polar axis, if we rotated it that way, opposite in the other direction is over here. Is that right? That's my radius of negative square root of 2. Right in here, this value there. So that's why I can also describe this using the information we found algebraically as negative square root of 2 positive 7 pi over 4. So there's actually two ways here using this r in theta to describe that point. And this is every gory detail. So how do I really know I'm on the right track? Go back to this rectangular coordinate version and think about what quadrant that solution is. That always tells you what values for r and theta you're going to have. So there's two ways we could do it. Here's my first way. Here's my second way, because this is not unique. And that happens when you convert from rectangular coordinates to polar coordinates, you're going to have possibly this issue. So that's why I kind of want to go over this in this detail, because you guys should know how to handle that, you know. And hopefully you guys appreciate the detail. Anybody have any questions on the work we just did? Yes?
What do you mean there will be an answer in quadrant 4 as well, since radius could be positive?
Okay,
Negative.
here's the question. I'll repeat the question. The question is this. Let me erase all this detail, okay? Let me remind you, when you plot the rectangular coordinates, -1, 1, that is the only location of a solution, or I should say, -1, 1 is very clearly in quadrant 2. Okay? There is no other point as a solution in any other quadrant. Does that make sense? Because that rectangular solution, you're superimposing the rectangular coordinate system over the polar coordinate system. So if you have only one solution there, you're not going to have any other. It's just there's different ways to describe the polar location. In fact, there's infinitely many ways. I can add multiples of 2 and pi to every angle, you know. They're not well defined. They're not unique.
So if they only gave you tangent -1, then there would possibly be two different angles.
There's two ways to describe. In fact, there's infinitely many ways. But when I say to you, what does this information mean? Because you got, you know, two values for r, and you got two angles, you know. And people go, how do I put that information together? I'm confused. How do I handle the two radius and the two thetas? Choose one if you want. But there's many ways to describe it because it's not unique. So I went through using both information, positive square root of 2 right here, and positive 3 pi over 4, negative square root of 2, positive 7 pi over 4. The point is, again, they're both describing this single location over here in quadrant 2. And that's the difference. So when you go from rectangular to polar, there's going to be some deduction. Okay, you okay with that? And how do you know what the answer is? Use your definitions and what's consistent with whatever quadrant that rectangular coordinate is in. If it was in quadrant 1, then use the information for r and theta consistent for a quadrant 1 answer. If the rectangular is in quadrant 3, well, use the polar information consistent with quadrant 3, and so on and so forth. If it's in quadrant 4, your rectangular coordinate point is in 4, use the polar representation that describes a quadrant 4 solution. That's it. That's it. So I could have said to you, you know what, you guys, I'm done right here. My work is over. There's my solution. I converted that first one. Okay? But we have to know, you know, every detail because it's there. Example. Let's continue. What if they gave us? Let's see if we're awake. negative square root of 6, negative square root of 2. Again, this is what? Is this rectangular? It is. This is x and y. So let's bring out r. R squared is x squared plus y squared. Tangent theta is y over x. R squared, what's r squared? Negative square root of 6, negative square root of 2. R squared is 8. What does that mean about r? Plus or minus square root of 8. Do you guys know this is 2 square root of 2? Okay, you okay with that? So let's put this in blue here. That I have two radius values again. R would be plus and minus 2 square root of 2. Let's find out theta. Tangent theta is, what's the ratio? Minus square root of 2 over minus square root of 6. Tangent theta, what's this? Positive square root of 2, square root of 6. I don't know, is that a special angle I can kind of, isn't that the square root of 2 over 6? Or I should say tangent theta is square root of 1/3. Tangent theta, 1 over the square root of 3. Anybody happen to know what this is? What's the definition? Opposite over adjacent. Oh, that must mean this is what? 2. What's theta going to be? Everybody know what theta is? What's theta? Is theta bisected? Isn't theta, am I right? Theta is bisected, pi over 6, pi over 3. What is theta? Is that 30 degrees? Okay. Now remember, you're trying to find solutions to this equation. See your last homework. What do I mean by that? All students take calculus. Where's tangent positive? Quadrant 1. Isn't this quadrant 1? Quadrant 2, quadrant 3, and 4. Okay, my reference angle here is pi over 6. That's one of my solutions. Let me put it in purple. Pi over 6. Where's my quadrant 3 answer? Pi plus what? Pi over 6. We get 7 pi over what? 6. These are my two solutions. So notice here, I'm going to tell you, what do we do with this information? In other words, what does this mean again? Let's go back to this graph. If I'm smart, I hope I am, let's see if we can do what? Oh, there it is. Beautiful. Just paste. So let's see, what does this information mean? What do I have? I have two values for r. So I'll say r is plus or minus 2 square root of 2. Theta is pi over 6. Theta is 7 pi over 6. Double check. My rectangular coordinates are really negative square root of 6, negative square root of 2. So I'm going to think about what quadrant my solution is in. X-axis, y-axis. Both negative. What quadrant is this? 1, 2, 3, 4. So what quadrant is this solution going to be in? Anybody want to tell me? If they're both negative, here's negative, here's negative. Isn't that quadrant 3? Okay. It's a quadrant 3 solution. Is that true? So I'm going to say to myself, I know this point is in quadrant 3. Okay. Can I come up with an r theta that's consistent with quadrant 3? You know what I'm going to use? I'm going to use my pi over 6. Take the polar axis, rotate it 30 degrees, pi over 6. Okay, you guys with me on this? So every angle in this purple region has a radius value that's positive. So far, so good? So if I say to you, I'm going to use a theta being pi over 6, I can. There's my theta. I need a radius. If I use the pi over 6 angle, what does this radius have to be? On the other side, this is where all the negative radius values are. So what am I going to use? Negative 2 square root of 2. This is my what? Solution. And so this is how I convert from what? Rectangular to polar. Okay, anybody have any questions on that one? That one's a pretty good one. Remember, every radius value out here is what? Negative. Every radius up here is positive. Yes?
Would it be okay if we were to write 7 pi over 6?
Yes, it would be. If you said, hey, you know what? I want to use my, well, is 7 pi over 6 in quadrant 3? It sure is. It's right here. Good. If you said, you know, I think I'd rather use 7 pi over 6 as my angle theta, that's perfectly fine. But you're now going to have to tell me, let me erase this now. What you're saying now is this. Get rid of this. Get rid of that. Get rid of this. Even get rid of this. Polar axis, where's 7 pi over 6? It is, but is it over here? Oops, sorry. Pi over 6 is 30 degrees, is that right? 210. This is where your angle of 7 pi over 6 would be. And every value for r on this purple region here, what do we say? Positive. So you're going to have to use what value for r? Positive. That's another way of describing that same point. Okay, so you can actually put a dot, I guess, where it's at, and say, you know, 2 square root of 2, I don't know, it's somewhere maybe right here, who knows? I'm not going to go through that detail. The point is it's in quadrant 3 on that axis there, on that angle, and you have now converted from what? Rectangular to polar, but just keep in mind, doing so requires a little bit extra. Is that right? You got to be awake. You got to deduce, because you got 2 values for r, you got 2 values for theta, and so there's different ways of describing that angle. Just use the information. All right, good job.